Let's say we have a chemical reaction where one molecule of nitrogen gas reacts with three molecules of hydrogen gas to produce two molecules of ammonia. In chemical reactions, you might have seen this arrow, probably seen this arrow a million times, and you might think, oh, chemical reaction, can only happen in the forward direction, right? So a chemical reaction can only happen in the forward direction, like this way. So it's kind of like once you get to your products, you can't really go back to where you started. That's not actually true. And chemical reactions, they can do something, they can happen in reverse, okay? So they can kind of happen the opposite way. And what that means is, so let me just write out the reaction. And you can see how in our first reaction, our forward reaction, one molecule of N2 reacts with three molecules of H2 to produce this. And in our second reaction, our product, actually, we're going from our product and we're going back to our reactants, okay? So in the forward reaction, this, right, N2H2, they react, form ammonia. And the second reaction, ammonia breaks back to these individual molecules. And this reaction is something called a reversible reaction. So a reversible reaction happens just in both ways. And the way you symbolize this is by this double arrow right here. All right, so one half of the arrow going this way, one half of the arrow going this way, the other way. So if you were to write this out, all right, this would look something like this. And you can see this reaction right on the bottom is basically symbolizing these two reactions right here, okay? So N2 and H2 is reacting to form NH3, and NH3 is breaking back up. It's decomposing back into N2 and hydrogen gas. All right. Chemical reactions, they can also be in equilibrium. And chemical reactions in equilibrium, one thing you need to know is that the rate of your forward reaction, so forward reaction, is equal to the rate of the reverse reaction. All right. So the rate of the forward reaction is equal to the rate of the reverse reaction. So once again, if I write out the same reaction that I did before, so same reaction I did before, this. All right. Let's say that every 5 seconds, so let's say every 5 seconds, N2 is reacting with H2 to form NH3, two molecules of NH3, while every 5 seconds, the same thing would be decomposing back into its original components, all right? So if every 5 seconds, these two things reacted to form NH3, well, at the same time, this NH3 would be breaking down into N2 plus 3H2, all right, at the same rate, okay? So at equilibrium, the rate of forward reaction equals the rate of the reverse reaction. And another thing to know about chemical reactions, so right now I've drawn a diagram. So let's say we have this 1 liter container and it's filled with all of these molecules, all right? So the molecules from our chemical reaction. Now, let's say that, right, every 5 seconds, all right, so every 5 seconds from this reaction, 3 hydrogen gas is going to react with 1 molecule of nitrogen gas, right? So 3 hydrogen gas, 1 nitrogen gas, and we're going to produce 2 molecules of ammonia. All right, so let's see. We produce 2, all of these react. We produce 2 molecules of ammonia. All right. And let me just erase this, okay? Because they've reacted, all right? Well, we know that the rate of our forward reaction is going to be equal to the rate of our reverse reaction. So as those three molecules of hydrogen gas and this one nitrogen gas, right? Remember they were just right here and they reacted to form these two molecules of ammonia. At the same time, two molecules of ammonia during these 5 seconds, they're going to decompose back into N2 and the three H2s. All right, and the H2s that just they're gonna decompose back into this. So you can see how we basically, all right, so if I erase this now, because these two ammonias, they just reacted with each other. All right, so they ain't gonna be here no more. Let me just erase all that. You can see how before the reaction, right, before the reaction, we started off with 6 molecules of H2 and 2 molecules of N2 and 4 molecules of NH3. And at kind of our first cycle, right, our first cycle, when 5 seconds happens and all of this reacted, we ended up with the same amount of stuff, right? We still ended up with 6 molecules of H2, 2 molecules of N2, and 4 molecules of NH3. So the concentrations of our reactants and our products, they're going to be constant, okay? They're not going to be equal to each other. That's a lot of people think they're equal to each other, but they're not. You can see how there's 4 molecules of products on this side, and there's, in this case, there's 6 molecules of H2, 2 molecules of N2, right? The concentrations are different, but you can see how over time, when all of this stuff is happening, the concentration of reactants and products, they're going to be constant.